So here it is the window for the Ansys Workbench. After initializing the process, it opens out this Ansys Workbench, that is 2020 R2 version window. Okay, so as you open out this particular window, you will be just finding out the different types of options in this at the extreme left. Okay, starting from the coupled field static, gen value buckling. So there are different modes of doing out the analysis, but as we are restricted towards the beams, that is deflection and deformation to be checked out in the beams, will be just restricting towards the static structural environment for solving out the beam problems. Either it may be related to your cantilever type of beam, or either it may be simply supported beam, or it may be a column. Okay, where we'll be doing or checking out the deformation and other terms such as SFD, BMD that will be developed out in that particular beam. So we'll be starting out with the static structural for this problem that we have discussed out. I will just the initial step. Okay, it is to drag out the static structural into this project schematic window. Okay, so in that particular red box, you have to drop out the static structural uh, option. Once you drop out that particular static structural option into that red box, there will be several streams that you will be getting out. That is step-by-step procedure for solving out the problem. As we discussed out, the problem that we are solving, it is cantilever type, whose one end is fixed and other end carries out a point load of 6 kilonewton. The span of that particular beam, it is 4 meter, and the cross section, it is 0.35 meter by 0.35 meter. Okay, so I have just dragged out the static structural into that red box. Once I just drop out the first point, it is the static structural. There are total 7 points. You can just check out 1 2 3 4 5 6 7. Okay, till third point is very much important too, or these are nothing but the different steps by which we are going to solve out this problem. The first point, it is to choose out the material. Okay, so if you don't allot any material, okay, for this particular problem or for this particular beam, it is already been shown out in front of the engineering data. It is shown, it is showing out a tick mark. That is, it is this Ansys Workbench assumes out the material by default. That is, it assumes out structural steel as the material for the beam. Okay, if you just check out, I'll just right click on the engineering data and click on edit option. You can just find out the structural steel material. Okay, it will just take out some. Okay, here it comes. You can just check out, by default it takes out the structural steel, where you are having the isotropic elasticity, which gives out the Young's modulus, Poisson's ratio, bulk modulus, shear modulus. You can also vary out the material. You have to add out the material and you have to enter out its isotropic properties. For example, Young's modulus, Poisson's ratio, bulk modulus, or shear modulus, if you just wish to vary out the material. But for the given problem, you will be just continuing out with the same problem, or by using out the default material, which is structural steel. Okay, which has been already taken out by default by the Ansys Workbench 2020 version. So I'll just close out this particular window, and again I'll be just going back to the project schematic window, and I'll be just shifting towards the third point, that is geometry. Okay, so I'll just right click on geometry. I will right click on geometry option, where I will be getting out two windows. Okay, first, that is the new space claim geometry, and second one, that is the new design modeler geometry. So out of these two options, I will be just going ahead with the new design modeler geometry. Okay, this new space claim is very much new. Okay, for this 2020 version, so I'll be just going ahead with the DM mode, that is new design modeler. So I'll just click on new design modeler. So once I just click on new design modeler, it opens out the new tab for drawing out the geometry of this particular beam. Okay, so in this geometry, we'll be drawing out the beam. That is, I'll be first of all drawing out the beam, creating out the line. Then I'll be just assigning out the cross section for that line. Okay, so I can just go ahead for the next steps for solving out that, or to checking out the deformation that will be developed out in that particular beam. Okay, so it takes out some time because the geometry window is new. Okay, once the step that we have followed out in this third category, that is we have just right click on geometry, and in which we have just chosen out the option of the new design modeler, okay, for drawing out the geometry. Okay. It takes some time for opening out the window, just for a minute. It will take few seconds for opening out that new tab where we can start out to draw the geometry, that is creating out the line and assigning out the cross section for that line. Okay, already we know that the cross section for this beam, it is square, that is 0.35 by 0.35 are the width and the height respectively, with a length of 4 meter. Okay, which has been already shown out. Units by default, it will just units, it will just consider out by default the answers takes out in meter only. You can change out if you just want to vary out the units. Okay, I'll be also telling out that here is the option where you can just vary out the units. Okay, by default it will be just switching on the metric mode only. Okay. Yes, now this is my design modeler window where I'm going to just draw out the line, that is 1D line I'll be creating out. So in that case, I'll be just clicking out first of all tree outline. I'll be selecting out the XY plane first. So once I just select out the XY plane, I'll be just clicking right click. I'll be, and on that basis I'll be just going on the view. Okay, I'll be choosing out front view, which is very helpful for drawing out that particular line. So once I just select out that particular front view, again I am going back on tree outline and I'll be going with the sketching part. You can just check out at the extreme left at the bottom there is a sketching option. So I'll be just click on that. I'll be clicking on that sketching option. Once I just click on that sketching option, this different icons or this different tools will be opened out. So in that case I'll be choosing out the first tool, that is the line option. Okay, so I'll be choosing out the line option and I'll be drawing out simply this line. Okay, once I finish out this particular line, it is you know that it is cantilever which will be fixed at one end and which is carrying out point load at the free end. Okay, so once I just finish out the line, again I'll be clicking on the sketching toolboxes and I'll be selecting out the dimensions option. Okay, it is required or it is essential to dimension out this particular line. So I'll be clicking on this dimension option, and once I just click on the dimensions option, I'll be just selecting out the general option and I'll be just selecting out the line. So you can just check out once I just click on the line. Okay, it shows out the dimension. Okay, so here in this particular detail view window, the h1 value it is 17.144, but in problem it is 4 meter. So I'll be just entering out that 4 value. Okay, which completes out my line. Once I complete out my line and the dimension for that line, I will be going on the concept tool. I'll be clicking on that concept tool. Once I just click on that concept tool, I'll be going ahead with the second option, that is line from sketches, and I'll be clicking on that. Once I just click on line from sketches, I'll be selecting out that line that we have drawn out of 4 meter. Okay, and I'll be applying out the add frozen option for this line, and once I just finish out this add frozen option, I'll be generating out this particular line. So it takes some time. It is necessary to have this particular process, that is add frozen, because we want to connect out at 2 points, that is fixed point and the point where we are going to apply the load. Okay, so once it becomes out that generate, once the add frozen option has been selected out and will be generated, we have generated out the line. Okay, it finishes out that particular add frozen task. Then again we'll be going back to the concept option where we are going to define out the cross section for this line. Now we know the cross section of this particular beam, it is square. Okay, that is 0.35 by 0.35 meter. So I'll be choosing out the cross section as rectangular. Okay, from the option. That is, I have just gone from the concept step and I'll be just choosing out the cross section. It is rectangular. I'll be clicking on the rectangular term. Once I just complete out that, okay, again in the detail view window, I'll be entering out the width and height of this particular cross section, which is 0.35, and also my height it is 0.35, which completes out the square. You can just check out a new blue box has been formed out. Okay, you can just check out. Okay, once I just finish out drawing out the cross section for this particular line, now I'll be just again clicking on the tree outline. Okay, and in the case of this tree outline, I'll be clicking on that plus option, that is one part and one body. Okay, because for this particular line, it is essential to assign out the cross section. Okay, cross section यहाँ पे देना चाहिए. So I'll be clicking on that one part and one body option. Once I just click on, there is a line body option, and I'll be clicking on that line body option. Okay, and we have to select out the cross section because and it is essential to assign out the cross section for this line. So I'll be assigning out the cross section that we have defined out, that is rectangular of 0.35 minute 35 meter height and width. Okay, so once I just define out the cross section for that line, okay, again I'll be going back to the main window, that is project schematic, and you can just check out in front of the geometry. Again there is a tick mark, that is we have just followed out the correct process. That is, we have drawn out the line first of all, and then we have just assigned out the cross section for that entire span of the of 4 meter, that is 0.35 meter into 0.35 meter. Okay, so once I complete out with the third step, now that there is a last step, that is to model out this particular cantilever. That is, we have to give out the boundary condition and apply out the forces for checking out the deformations that will be developed out in this beam. Okay, so the third, I'll be moving towards the fourth option, which is the last option, when which will be opening out the mechanical window. Okay, so once I just move towards the fourth option, I'll be just clicking on the model option, and I'll be clicking on edit. Right clicking the model, and I'll be clicking on the edit option for opening out the mechanical window, where we are going to apply out the boundary conditions, okay, for this problem, and applying out the forces to generate out the deformations that will be developed out in this problem. Okay, it takes some time for opening out the mechanical window. Few seconds are required for opening out that mechanical, that is fourth step window.